Dear learners, greetings. After learning two measures of central tendency, that is mean and median, let's today learn about the third measure of central tendency, that is mode. So first, let me explain what is mode, what are its characteristics, and then definitely we will learn how to calculate mode. And for that, I have taken plenty of examples so that you may understand. So what is mode? There are some definitions. One definition, the first definition, the mode is the value which occurs most frequently in a distribution. So mean or median, mode is quite different. So in the mean, if you remember what we do in order to calculate mean, we sum all the numbers and divide it by the total numbers, and then we get mean. And similarly in the median, what we do, we arrange the data in ascending order, and then we locate which one is in the middle, and that will be the median. But in mode, we don't do anything like that. So mode is what? We see the data set and see in the data set which number is occurring most of the time, most frequently, most number of time. That will be the mode. Coming to the second definition, repetition of certain kind of first definition. Mode is the value which is repeated most often in the data set. So simply we count which data has repeated itself most number of time. Coming to the third definition, the mode is that value of the variable which appears most frequently in a distribution. And the last definition, the mode of a distribution is the value at the point around which the items tend to concentrate, and it is the most typical or representative value. So here the typical or representative value will be that number which occurring most of the time. So what are the characteristics of a mode? Definitely, if you see, it's very easy to calculate because you need not to arrange the data in ascending order, or you need not to find out the sum. I mean, nothing like that. Whatever the data has been given, just you have to count which one is appearing most of the time. So it is very easy to calculate, and uh, it shows the highest frequency, definitely, and it does not require complex formula or complex calculation as in the case of mean and median. And it's the only measure of central tendency that can be used with nominal data. And what is nominal data? Already it has been explained to you. We have nominal, ordinal, interval, and ratio data. So mode is most suitable if the data has been taken nominally. And of course, it is suitable for both numerical and categorical data. It is one of the important characteristics of mode, and it can be represented graphically as well. So these six are the important characteristics of the mode. Now, let me explain the types of mode. So as you know, when I taught you mean, I explained that mean is represented by the capital M, letter capital M, and median is represented by capital M and small d. Similarly, mode is represented by capital M and small o, MO. So mode is represented by MO. And there are by and large three types of mode. Unimodal. So unimodal is what? In the data, there is one number which is appearing most of the time. So that is only one mode is there in that particular data set, in that particular distribution. So that is known as unimodal distribution. So what is unimodal distribution? In a data set in which only one number appears most of the time. Whereas sometimes this is a situation that in a data set, two numbers appears. I mean, three times two numbers are appearing, or five times two numbers are appearing. I mean, something like that. So in that situation, there are two modes. So we say that distribution is bimodal distribution. Similarly, sometimes if you have collected a large data, so it happens that there are three numbers, or more than three numbers, or more than two numbers, which are repeating themselves so many times. So in that situation, it will neither be unimodal nor it will be bimodal. Rather, it will be a multimodal distribution. So which distribution is a multimodal distribution? In a data set in which there are more than two numbers appearing same number of times. So that is multimodal distribution. So after learning what is mode and its characteristics as well as its types, let's come and see how to calculate mode. So what you will do, I mean, there is no complex formula, there is no complex method. It's very simple. Just see the data and see which number is appearing most of the time. So one example is there on the slide. If you see, uh, 23, 24, 16, 13, 19, 19, 20, 15, 19, 21, and 14. So this is a distribution, and you see 19, see 19, 19, and 19. So 19 in this data set is appearing most of the time. In other words, we can say that 19 has the highest frequencies. Highest frequencies means what? The number which is appearing maximum number of times. So since 19 is appearing 3 times, so it has the highest frequency. So we'll say that for this particular data set, the mode is 19. So how you will calculate? Nothing you have to do. See the data, see the numbers, see which number is repeating maximum time. So if it is only one number, things are very simple. That will be the mode. If there are two numbers or more than two numbers which are repeating same number of times, so for that we will use another formula that we will be discussing later on. So in order to let you understand, let me take few more examples. Let's do some more exercises and then we will proceed further. So I have taken this particular example. You see, this is a distribution. Numbers have been given, as you can see: 54, 70, 91, 92, 34, 56, 51, 77, 92, 63, 30, 71, 37, 45, 92, 32, 53, 62, 29, 38, 57, and 92. So this is a big data set. So many numbers are there. Now you have to calculate the mode. So remember, how will you calculate the mode? You have to do just nothing. Just you see which number is in fact repeating most of the time. So you see the data. I think 92 one time, 92 another time, 92 third time, and 92 fourth time. So 92 is that number which has the highest frequency or which is repeating most of the time. So it will be the mode. Further, you can ensure that there is no other number which is repeating as many times as 92. Suppose 54. So 54, if you see, it is only once in the data. There is no other 54. Similarly, if you check 70, you will find there is only one 70, no other 70 in this whole data set. Similarly, if you see 91, there is only 191 in this whole data set, and definitely, I mean, its frequency is just one. So by that way, you can say that mode MO is equal to 92 for this particular data set. Why? Because 92 has appeared most of the time. 92 has the highest frequency. Coming to the second example, if you see, numbers have been given. You see 32, 67, 55, 53, 68, 55, 35, 39, 81, 65, 55, 33, 38, 47, 56, 55, 98, 89, 55, 27, 30, and 55. So we have to calculate the mode of this data set. And remember, how will you calculate the mode? You have to see which number is appearing most of the time. So you start checking. I think 55 is such a number which is appearing more than once. How? So one time, second time, third time, fourth time, fifth time, and sixth time. So 55 is such a number which is appearing in this data set 6 times. So 55 has the highest frequency 6. There is no other such number which has repeated itself in this data set 6 times. If you check 32, it's appearing only once. There is no other 32 in this whole distribution. If you see 89, 89 is appearing only once. Only once. If you see this whole data set, you will not find 89 anywhere else. So that is the frequency of 32 is only 1. The frequency of 89 is only 1. If you check 98, again you will find there is no 98, other 98 in this distribution. So by that way, I mean, if you keep on checking the other numbers, for example, let me take 67. So 67 is such a number which is again appearing only once in the data set. So by that way you can say that 55 is the only number which is repeating itself 6 times. It has the highest frequency. So definitely the mode for this distribution will be what? 55. So the calculation of mode is of course very easy in this situation when you check which number is repeating maximum times, and by that way you determine the mode. Let's continue and see on the next slide. Few more examples have been written for you. So if you see first number, I mean in the first example, in the first data set, the numbers I'm repeating 23, 29, 13, 14, 18, 13, 25, 9, 23, 17, 23, 15 and 30. So you are required to calculate the mode for this data set. So what you will do? Definitely you will see which number has the highest frequency, or in other words, which number is repeating maximum times. So you see 23 is such a number which is repeating maximum times. How? Here it is 23. If you move forward, you will find here it is 23. Further, if you'll move forward, you will find 23 third time. So in this data set, in this data of numbers, 23 is the only number which is repeating more than once. Right? Can you see? Is there any number which is repeating itself more than once? Yes. How? 13. If you see another one, 13. If you see another one, 30. Now I'm making double circles. I'm making double circles. So 13, 13, 13, 3 times, 13 3 times, and if you see 23, again 3 times. So this is a very unique situation. This is a bimodal distribution. Why bimodal distribution? Because there are two numbers which are repeating more than once, and both the numbers, if it would have been happening like this, that 23 has repeated itself 3 times and 13 has repeated itself only 2 times, then no problem, 23 would have been the mode of this distribution. Or if this case would have been like this, 13 has repeated itself 4 times and 23 has repeated itself 3 times, then 13 would have been the mode. But this is a very unique situation in which two numbers are repeating same number of times. That is, two numbers have the highest frequencies, that is 23 and 13. So this particular data set has two modes, and in that situation, how you calculate mode? MO is equal to, what you will do? You will take the mean of these two numbers. So 23 plus 13 divided by 2. So this will be your mode. So how? Because two numbers are repeating same number of times. So you have to find out the mean of that. Now you keep on summing it. You will get 36. So 36 divided by 2. So finally 18 will be the mode. This will be the mode of this particular distribution. You can further check, is there any other number which is repeating itself? No. There's no other number which is repeating as many times as 23 and 30. So both numbers are repeating 3 times. So finally, the mode will be 23 plus 13 divided by 2. So that is 18. Now, let's come to another problem. Just a problem has been written on this particular slide and you see the data. So I'm repeating the numbers: 67, 34, 45, 67, 87, 34, 77, 43, 31, 67, 57, 53, 59, 69, 73, 34, 49, 67, 61, 71 and 34. So these are the numbers which have been given and you are required to find out the mode. So what you will do? You see which number is repeating maximum times. So I think 67 is such a number which is repeating maximum times. So 1, if we'll move ahead, you will find here 67 2 times. Again, if you'll move, you will find third times. And again, if you'll move, you will find fourth time. So 67 is such a number in this distribution which is repeating maximum times, that is 4 times. But at this juncture of time, it's important for you to check, is there any other number which is also repeating? For example, let's take 34. So 34, 34, 34 and 34. So again, I mean, this is the situation that 34 is repeating 4 times in the same way as 67 is repeating 4 times. So let me make a triangle. Let me make a triangle. This, this, and this. So 67 is repeating 4 times. 34 is repeating 4 times. Let me check whether is there any other number which is also repeating itself. So let's check 45. So 45, if you see in the whole data set, it has appeared only once. Similarly, let me check 87. So 87 is such a number which is appearing only once in the whole data set. Similarly, if you check 77, again you will find that 77 is appearing only once in the whole data set. So definitely there are only two numbers which are repeating themselves more than once, and they both are repeating themselves same number of times, that is 4. So finally, in order to calculate mode, what you will do, in order to calculate mode, you will find the mean of these two numbers. So how you will find the mean of these two numbers? Definitely you will sum it up, that is you will sum 67 and 34, and whatever the sum comes, you will divide it by 2. So let me calculate. So 7 and 4, 11, and 6 and 3, 9, and 1, 10. So it is 101 divided by 2. The moment you will calculate, you will find that it is 50.5. So finally, the mode of this particular data set comes out to be 50.5. So again, these two examples, through these two examples, you can understand that these two examples belong to bimodal distribution. That is, both the data set have more than one mode, that is two modes. So we'll say that it is a bimodal distribution. Let's continue and do some more examples. So these two examples, numbers are so many, numbers are more. So definitely it will be easy and it will be better for you to calculate. So let me take this example. Let me first repeat the numbers: 33, 33, 56, 78, 91, 56, 58, 34, 33, 78, 66, 88, 91, 53, 45, 45, 56, 29, 34, 59, 78, 79, 81, 71, 45, and 91. Now, see which number is repeating itself maximum time. So, let's see: 33, one time, second time, third time, Then if you move ahead, uh, that's it. So 33 is repeating 3 times. If you see another number, so 56, I'm making a triangle, 56. Then if you move ahead, uh, so I think 56, one more. So let's check it. 56 once, 56 twice, and in this whole data set, 56 appears thrice. Now, again, this is the situation in which two numbers are appearing most of the time. Two numbers have the highest frequency. 33 has 3 frequency, that is 33 has appeared 3 times. Similarly, 56 also has appeared 3 times. So, in order to calculate mode, what you will do, you will find the mean of 33 and 56. That is, you will find the sum of 33 and 56 and divide it by 2. So it will be 9 and 89. 89 divided by 2. So finally it is 44.5. So 44.5 is the mode of this particular distribution which you were just studying. And again, this is a case of bimodal distribution. Why a bimodal distribution? Because two numbers are repeating themselves same number of times, and they are 33 and 56. And in order to find out the mode, we have got the mean of 33 and 56, and finally we have got 44.5. Now let's come to the last example, which is there. Again, it's a very big one. It's a very bulky one. So many numbers are written here. So first let me repeat. It is 71, 57, then 51, 68, 39, 71, 39, 57, 87, 97, 45, 96, 73, 85, 43, 96, 71, 84, 10, 75, 39, 86, 53, 86, 97, 84, 43, 27, 29, 64, 57, 84, 92, 94, 56, and 97. Now, for this data set, you are required to calculate mode. So, let's see which number is repeating itself maximum times. So, let me take first 71. So, 71 once, 71 second time, move ahead, 71 third time, and if you keep on moving ahead, I think maximum number of times 71 has appeared 3 times. So is there any other number which is appearing more than once? Yes. It is which number? 57 once, come forward, 57 second time, come forward, 57 third. So check it. 57 first time, move ahead, move ahead, move ahead. So 57 two times, move ahead, and then 57 third time. Now say it minutely. Is there any other number which is also repeating itself? So yes, and that number is 39. So I am making a rectangle like this. So 39 once, 39 two times, move ahead, move ahead, move ahead, 39 third time, move ahead, move ahead, move ahead, and that's it. So this is a very unique case. This is a case of multimodal distribution. Why? Because more than two numbers are repeating themselves same number of times. So first 71 has repeated it 3 times, then 57 has repeated it 3 times, and finally it is a 39 which is repeating itself 3 times. So in this particular situation, mode will be the average or the mean of 71 and 57 and 39. So you will find the sum of these 3 and divided it by 3. So if you will keep on calculating, so you will find that the sum has come out to be 167 and you have to divide it by 3. So remember, check the calculation minutely. So 1 and 7, 8 and 9, 17, 7, 1 carry, 7, 1, 8 and 5, 13 and 3, 16. So 167 divided by 3, and the moment you will do the calculation, you will find that it has come out to be 55.66. So finally, we have got the mode of this distribution as 55.66. So out of all the examples that we have taken and out of all the problems that we have solved, in fact, this was the most peculiar. Why? Because this was the case of a multimodal distribution. Three numbers repeated themselves 3 times, and in order to find the mode, we in fact got the average of all the 3 numbers or mean of all the 3 numbers. So through these examples, I think now you will feel yourself comfortable in calculating the mode. So let me summarize. See the data. In order to calculate the mode, see the data. Which number is appearing most number of time? If it is only one number that is appearing most number of times, that will be the mode. But if there are 2 numbers and they are appearing same number of times, so you have to find out the sum of these 2 and divide it by 2 in order to get the mode. And if there are more than 2 numbers, in that situation, in order to get the mode, you have to find out the average or the mean of those 3 numbers or 4 numbers, whatever the case. So in a nutshell, this was the procedure to calculate the mode from the ungrouped data. So far as mode from group data is concerned, in the coming lectures, we will tell you how to calculate mode from the group data, because the group data procedure is different. It is a little bit lengthier and it is a little bit cumbersome also. At this juncture of time, let's see when we use mode, it will be better for us to use mode. In the beginning, I have mentioned that mode is a measure of central tendency in the same way as mean and median. And the moment I explained mean and median, I told you what will be the situation in which we will preferably use mean and median. Similarly, let me discuss what will be the situation in which we will be using the mode. Simple. When quick and approximate measures of central tendency is needed. Let me give you one example. There is one company, which makes, suppose 5 products. All the products are good, all the products are costly. So that company wants to know, out of all these 5 products, which product is most popular. So what that company will do, it will ask its customers which product you like most. For example, it has taken the data from 200 customers, or it has taken the data from 500 customers. So they have coded for every product. For product 1, they have given the code 1. For product 2, they have given the code 2. For the product 3, they have given the code 3. For the product 4, they have given the code 4. And for the product 5, they have given the code 5. So maximum number of times they will see which number is occurring. So they will ask first customer, suppose he or she says 1. Similarly, 10th customer, 20th customer, they will move on and their preference they will note, and out of all the data they will see which number is appearing maximum time, and by the virtue of that they will be able to tell which product is the most popular product, which product is most liked by the customers. So when quick and approximate measure of central tendency is required, we use mode. Nothing you have to do, no lengthy calculations, no complex formulas, just you have to see which number is appearing maximum number of times. Sometimes we are interested in knowing some typical values. In that situation also we can use mode. When the data is non-numerical, sometimes we collect the data in which we get the non-numerical data. So in that situation also we can use mode. When the most frequently occurring value is required, mode will be the best. And when identification of many subgroups or clusters are required, in that situation also we can use mode. So let me explain the advantages of mode. the biggest advantage of mode is that it is very easy to understand, easy to calculate, easy to tabulate, and easy to interpret. It's very suitable for qualitative data. And of course, as mean and medians are affected by extreme scores or outliers, mode is not affected by the outliers or the extreme scores. It is a third advantage of mode, and it represents the most typical value. And finally, mode is applicable to open-ended distributions also. But simultaneously, mode has some disadvantages also. And the biggest disadvantage, it ignores most of the data. Sometimes mode comes to be a very strange value, which is definitely not there in the data set, as in the previous examples you have seen. So by that way, sometimes mode ignores the data. Sometimes it is not suitable for further statistical treatment, like mean and median. I mean, in the same way, mode is not suitable or useful for the further statistical treatment. It is one of the shortcomings of mode. It is not always unique. I mean, sometimes unimodal, bimodal, or sometimes multimodal. This is the third disadvantage. It is unstable, particularly in small samples. Mode is less precise, particularly if you talk about group data, and definitely it is not suitable for uniform distribution of data. I mean, if the data will be uniformly distributed, no number is repeating more than once, then definitely in that situation you will not be able to calculate the mode. So these are the disadvantages of mode. But despite of these disadvantages, mode serves so many purposes in statistics, and in so many situations the researchers and the scholars and the scientists, they definitely use mode as the measure of central tendency. So thank you very much for listening to me. I have mentioned two books. These two books are very good, and very elaborately they have explained this whole concept. So in order to know further more about mean, median, and mode, I will recommend these two books. Go through these two books. Further knowledge you can get. Thank you very much. Now we will come with some other topic.